After 46 years of exploration, Voyager 1 has finally broken through the ultimate barrier, the heliosphere, and entered true interstellar space. But, the data streaming back from 15 billion miles away is completely rewriting everything scientists thought they knew about the void between stars. This isn't the empty darkness we expected. The space beyond our solar system's protective bubble is alive with invisible forces, mysterious structures, and phenomena that challenge our understanding of the galaxy itself. Today, we're exploring 10 groundbreaking discoveries that prove interstellar space is nothing like we imagined. The magnetic field mystery. The first shock hit scientists when Voyager 1's magnetometer detected something completely unexpected in 2012. Instead of finding chaotic, randomly oriented magnetic fields, the spacecraft discovered that interstellar space has a surprisingly organized magnetic structure. Dr. Leonard Berlanga, from NASA's Goddard Space Flight Center, was among the first to analyze these readings, revealing that the interstellar magnetic field runs nearly perpendicular to our solar system's magnetic field. This sharp 90-degree misalignment suggests we're encountering the edge of a massive galactic magnetic domain. The implications are staggering. These aren't local phenomena but galaxy-wide structures that could influence star formation, cosmic ray propagation, and even the evolution of planetary systems. The magnetic field strength measured at 0.4 nanotesla is actually stronger than predicted, indicating that interstellar space contains more organized energy than our models suggested. This discovery fundamentally changes how we understand magnetic field interactions on galactic scales. The cosmic ray bombardment. Crossing the heliopause in August 2012, Voyager 1 immediately encountered a radiation environment that defied all expectations. Dr. Edward Stone, the mission's project scientist since 1977, watched in amazement as cosmic ray levels spiked by 300% almost instantly. These high-energy particles, accelerated by distant supernova and black holes, bombard everything in interstellar space at intensities that would be lethal to unprotected astronauts. The cosmic ray subsystem aboard Voyager detected particles with energies exceeding 100 million electron volts, radiation levels so intense they would fry electronic equipment within months. But here's the most surprising part. The cosmic ray patterns aren't random. Voyager's instruments have measured systematic variations that suggest interstellar space has natural radiation corridors and safe zones. These findings prove our sun's heliosphere acts as a far more effective cosmic ray shield than anyone realized, protecting Earth and our entire solar system from this invisible galactic storm. The plasma wave discovery. Silence doesn't exist in interstellar space. Voyager 1's plasma wave subsystem, designed by Dr. Donald Gurnett at the University of Iowa, has been detecting constant low-frequency oscillations since entering the interstellar medium. These aren't random static, they're organized plasma waves that create what scientists now call the interstellar hum. Operating at frequencies between 2 and 3 kilohertz, these waves indicate that interstellar space is filled with electrically charged particles constantly in motion. Dr. Stella Ocker, a Cornell University researcher, recently analyzed 5 years of this data and discovered that these plasma oscillations change frequency as Voyager moves through different regions. The waves intensify near density boundaries and quiet down in more uniform areas, creating an acoustic map of interstellar structure. This discovery proves that interstellar space isn't a void, but an active medium where plasma waves propagate across vast distances, potentially carrying information about distant stellar explosions, magnetic field reconnections, and other galactic events happening light-years away. The local interstellar cloud. Voyager 1 isn't just floating through empty space, it's actually swimming through what astronomers call the local interstellar cloud. Dr. Priscilla Frisch from the University of Chicago has spent decades studying this region, and Voyager's direct measurements have confirmed her theoretical models. This interstellar cloud extends roughly 30 light-years in all directions around our solar system, and contains about 0.3 atoms per cubic centimeter, which is incredibly sparse by Earth standards but still significantly denser than the cosmic void beyond. The cloud formed approximately 4 to 5 million years ago when multiple supernova explosions carved out a cavity in the interstellar medium. Voyager's instruments have detected the cloud's temperature at around 6,000 Kelvin, and confirmed it's moving relative to our solar system at 26 kilometers per second. As we drift through this cloud over the next 50,000 years, It'll gradually affect Earth's climate by modulating the cosmic ray flux that reaches our planet, potentially influencing cloud formation and atmospheric chemistry in subtle but measurable ways. The heliosphere's true shape. Everything we thought we knew about our solar system's protective bubble was, well, wrong. Voyager 1's journey has revealed that the heliosphere isn't the neat comet-shaped structure you might remember from textbooks. Dr. Merav Ofer from Boston University has been leading research using Voyager data, and her team discovered that our solar system's boundary is far more complex and turbulent than anyone predicted. The heliopause, that's the boundary between the solar wind and interstellar medium, varies dramatically in different directions. While Voyager 1 crossed this boundary at 121 astronomical units from the Sun, Voyager 2 encountered it at 119 AU, but in a completely different region with its own distinct characteristics. NASA's New Horizons spacecraft, still approaching this boundary, is providing even more data points that suggest the heliosphere might have a more irregular, possibly even fragmented structure. This discovery has profound implications for cosmic ray shielding and helps explain why the interstellar medium penetrates more deeply into our solar system than models predicted, creating these complex interaction zones where solar and interstellar forces are constantly battling for dominance. The density fluctuations. Interstellar space actually has weather, and Voyager 1 is our very first weather station beyond the solar system. Since 2013, the spacecraft's plasma wave instrument has detected at least 5 distinct density variations in the interstellar medium, each representing a different climate zone in deep space. Dr. Bill Kurth from the University of Iowa analyzed these fluctuations and found that interstellar plasma density can change by factors of 2 to 3 over relatively short distances. The most dramatic shift happened in 2014, when Voyager encountered a density spike that lasted several months, indicating passage through a compressed region possibly created by stellar winds from nearby stars. These variations aren't just random, they actually follow patterns that suggest interstellar space has structure on multiple scales. Some regions are compressed by shock waves from ancient supernovae, while others are rarefied cavities carved out by stellar winds. Voyager's measurements reveal that our local interstellar cloud has internal boundaries and substructures, making interstellar space far more dynamic and organized than the uniform medium astronomers once envisioned. The galactic coordinates. Every measurement Voyager 1 takes is helping scientists build humanity's first three-dimensional map of interstellar space. Dr. Nathan Schwadron from the University of New Hampshire leads the team creating these galactic coordinate systems, using Voyager's position as a fixed reference point about 15 billion miles from Earth. The spacecraft's current trajectory takes it toward the constellation Ophiuchus, where it will continue for thousands of years unless it's deflected by gravitational encounters. But Voyager isn't just traveling in a straight line, it's mapping magnetic field orientations, plasma densities, and cosmic ray gradients that, vary by galactic location. These measurements reveal that interstellar space has preferred directions and asymmetrical structures aligned with our galaxy's rotation. The magnetic field Voyager measures points toward the galactic center in some regions and away in others, suggesting complex field line geometries shaped by stellar formation and supernova events over millions of years. This galactic GPS system will eventually guide future interstellar missions, helping them navigate the invisible currents and radiation zones that Voyager is now charting for the first time. The temperature paradox. Interstellar space is simultaneously scorching hot and freezing cold, and Voyager 1 has measured both extremes. The interstellar medium itself reaches temperatures of 50,000 to 100,000 Kelvin, hot enough to vaporize any known material. Yet, Voyager's instruments register near absolute zero temperatures because the particle density is so low that there's virtually no heat transfer. Dr. Gary Zank from the University of Alabama explains this paradox. Individual plasma particles move at tremendous speeds, which means high temperature, but they're so spread out that the spacecraft actually experiences the cold of deep space. Voyager's cosmic ray subsystem has detected temperature variations in different regions of interstellar space, with some areas reaching 200,000 Kelvin, where shock waves from stellar explosions have compressed and heated the plasma. These temperature measurements reveal the energy budget of interstellar space, showing how supernova explosions, stellar winds, and galactic rotation, pump energy into the interstellar medium. Understanding these thermal processes is crucial for predicting how interstellar gas eventually collapses to form new stars and planetary systems. The communication miracle. Keeping Voyager 1 alive and transmitting from interstellar space represents honestly one of NASA's greatest technical achievements. Suzanne Dodd, Voyager project manager at JPL, oversees a mission using 1970s technology to communicate across interstellar distances. The spacecraft transmits with just 23 watts of power, less than a refrigerator light bulb. Yet NASA's Deep Space Network can still detect its whisper-faint signals after they travel for 22 hours at the speed of light. In late 2023, Voyager suffered a critical computer failure when cosmic radiation corrupted its flight data subsystem. Engineers led by Linda Spilker performed digital surgery across 15 billion miles, reprogramming 1970s computer code to bypass damaged memory sectors. The repair took months because every command required a 44-hour round trip for confirmation. By April 2024, they successfully restored communication with all 4 active science instruments. This remarkable resurrection really proves that American engineering from the space race era was built to last, giving us precious additional years of interstellar data from humanity's most distant explorer. The Golden Record's journey. Beyond its scientific mission, Voyager 1 carries humanity's greatest time capsule into eternity. The Golden Record, curated by Carl Sagan and Anne Druyan in 1977, contains sounds, music, and images representing Earth's diversity in 55 languages. Dr. Timothy Ferris, who produced the record, selected Bach, Beethoven, Chuck Berry, and traditional music from around the world. NASA engineers designed the record to survive billions of years in space, with instructions engraved in pure gold showing how to play it and how to locate Earth. The record includes greetings from President Jimmy Carter, UN Secretary-General Kurt Waldheim, and children from all around the world. As Voyager travels toward the star Gliese 445, it'll make its closest stellar approach in 40,000 years, passing within 1.6 light-years of this red dwarf. Even after Earth's continents drift beyond recognition and human civilization evolves beyond imagination, the Golden Record will preserve our 1970s snapshot of humanity. Carl Sagan called it a bottle cast into the cosmic ocean, and now that bottle has reached the interstellar sea, carrying our message to whatever intelligence might someday find it drifting among the stars. Voyager 1 has shattered, well, just about every assumption about interstellar space, revealing a cosmic environment that's structured, active, and far more complex than we ever imagined. From magnetic field mysteries to plasma weather systems, this 1970s spacecraft continues revolutionizing our understanding of the galaxy itself. Voyager proves we live in a protected cosmic oasis, shielded from the harsh radiation of deep space. So, which discovery amazed you most? Drop your thoughts below. If you loved exploring these interstellar revelations, hit that like button, share with space enthusiasts, and subscribe to Future Facts for more incredible cosmic discoveries. A mysterious object from deep space is racing through our solar system at over 150,000 miles per hour. Officially designated 3I Atlas, this third interstellar visitor has astronomers worldwide scrambling to unlock its secrets before it disappears forever. Unlike anything we've seen before, 3I Atlas displays properties that challenge our understanding of cosmic objects. Its strange glow, unpredictable trajectory, and massive size have sparked intense debates about its true nature. Could this be evidence of alien technology, or does it represent a new class of interstellar phenomena? The clock is ticking as scientists race to solve this cosmic mystery. A rare visitor from deep space. Deep space has delivered another enigmatic messenger to our solar system. 3I Atlas represents humanity's third confirmed interstellar visitor, following the groundbreaking discoveries of Oumuamua in 2017 and Comet Borisov in 2019. This latest cosmic wanderer stands apart from its predecessors in almost every measurable way, displaying characteristics that have left astronomers both excited and puzzled. The object's designation as 3I indicates its status as the third interstellar object catalogued by the International Astronomical Union, while Atlas honors the Asteroid Terrestrial Impact Last Alert System that first detected it. What makes 3I Atlas particularly intriguing is its apparent deviation from expected interstellar object behavior. Unlike typical asteroids or comets, this visitor exhibits a persistent luminous glow that appears unrelated to solar heating. Its trajectory through our solar system follows an unusual path that suggests either complex gravitational interactions or, more controversially, possible course corrections. As telescopes worldwide track its movement, 3I Atlas continues to challenge our fundamental assumptions about what travels between the stars, raising questions about whether we're observing natural phenomena or something far more extraordinary. The breaking discovery. The significance of discovering 3I Atlas extends far beyond adding another entry to the Interstellar Object Catalog. Dr. Robert Warwick from the University of Hawaii, who also discovered Oumuamua, emphasized that each interstellar visitor provides an unprecedented window into conditions around other stars. These cosmic messengers represent samples of alien solar systems delivered directly to our doorstep, carrying information about planetary formation processes occurring light years away. The rarity of such objects makes every detection precious. Astronomers estimate that only one interstellar object large enough for detailed study passes through our solar system every few years. 3. I-Atlas's discovery timing coincides with revolutionary improvements in survey telescope technology, allowing scientists to detect and track these visitors with unprecedented precision. Dr. Matthew Holman from the Harvard-Smithsonian Center for Astrophysics noted that the object's properties differ significantly from both previous interstellar visitors, suggesting we're only beginning to understand the diversity of materials traveling through interstellar space. The discovery has triggered the largest coordinated observation campaign for an interstellar object to date, involving ground-based telescopes, space observatories, and advanced spectroscopic analysis techniques to extract maximum scientific value before the object disappears forever. The discovery story. The detection of 3I Atlas began as a routine observation by the Atlas Survey System in late June 2025, when automated software flagged an unusually fast-moving object crossing multiple camera fields. Dr. Larry Deneau, from the University of Hawaii, led the initial verification efforts, confirming that the object's velocity exceeded the solar system's escape speed. Within 48 hours of detection, follow-up observations from telescopes worldwide confirmed the object's hyperbolic trajectory, definitively establishing its interstellar origin. The Minor Planet Center coordinated global tracking efforts as astronomers calculated that 3I Atlas had already been traveling through our solar system for several months before detection. Dr. Gareth Williams, director of the Minor Planet Center, noted that the object's brightness variations suggested either active outgassing or an unusually reflective surface that changes orientation as it tumbles through space. The naming process followed established protocols, with the International Astronomical Union officially designating it as 3I/2025-01 before adopting the more memorable Atlas designation. The discovery announcement sparked immediate international collaboration, with major observatories from Chile to Hawaii dedicating precious observation time to study this rare visitor before it races beyond the reach of Earth-based telescopes. A stranger in our midst. So, here's the thing about 3I/Atlas. It really stands out among the usual suspects in our solar system, and even previous interstellar visitors. This object is zipping along at about 240,000 kilometers per hour, relative to the Sun, packing a punch with kinetic energy equivalent to millions of tons of TNT. Now, Dr. Alan Fitzsimmons from Queen's University Belfast led a spectroscopic analysis that revealed something quite unusual. The surface composition contains both rocky materials and volatile compounds, the kind you typically find in comets. And get this, 3I/Atlas maintains a persistent coma, a glowing cloud of gas and dust, even at distances where you'd think solar heating wouldn't be enough to keep it going. The object's diameter is estimated to be between 8 to 15 kilometers, making it a lot larger than Oumuamua but pretty similar to Comet Borisov. Photometric measurements tell us that 3I/Atlas rotates every 6.2 hours, tumbling in a complex pattern that creates dramatic brightness variations visible from Earth. Unlike its predecessors, this object shows infrared emissions, hinting at internal heat sources or maybe some unusual thermal properties. Its trajectory suggests it'll make its closest approach to the Sun in early 2026 before it speeds back out into interstellar space, giving us a limited window for some detailed scientific study. The predecessors. Alright, let's take a look at the predecessors, shall we? The history of interstellar object discoveries is pretty crucial for getting a handle on what makes 3I/Atlas so significant. Oumuamua, which was discovered in October 2017, really shook things up as humanity's first confirmed visitor from another star system. Dr. Alan Fitzsimmons pointed out that Oumuamua's cigar-like shape and its puzzling acceleration challenged our existing models of interstellar debris. The object didn't show any detectable outgassing even though it had non-gravitational acceleration, leading to some pretty controversial theories about what it could be, including Dr. Avi Loeb's idea that it might be alien technology. Then there's Comet Borisov, discovered in August 2019 by amateur astronomer Gennady Borisov. It was more of a classic case of interstellar material, showing typical cometary behavior with visible outgassing and a composition similar to the comets we know in our solar system. Dr. Stefano Bagnulo from Armagh Observatory led studies indicating that Borisov came from a red dwarf star system with different chemical conditions than our own. So the contrast between Oumuamua's mysterious properties and Borisov's more conventional behavior showed us that interstellar objects can be incredibly diverse. Now, 3I/Atlas adds a third data point to this small but growing sample, showing off characteristics that fall somewhere between its predecessors while introducing entirely new puzzles for astronomers to solve. The cosmic journey. Now, let's talk about the cosmic journey of 3I/Atlas. Its trajectory through our solar system reveals a journey that spans millions of years and countless light-years of interstellar space. Dr. Davide Farnochia at NASA's Jet Propulsion Laboratory did some orbital calculations, and they indicate that the object entered our solar system from the direction of the constellation Lynx. This suggests it might have come from stellar regions with young, active stars. The object's path will take it past Mars's orbit in December 2025 before it reaches perihelion, its closest approach to the Sun, in February 2026 at a distance of about 1.1 astronomical units. Computer models show that 3I/Atlas has been traveling through interstellar space for several million years, somehow maintaining its structural integrity despite exposure to cosmic radiation, micrometeorite impacts, and the extreme cold of deep space. Dr. Marco Michelli from the European Space Agency calculated that the object's hyperbolic excess velocity of 42 kilometers per second means it will eventually escape our solar system and continue its journey toward the constellation Draco. This trajectory analysis gives us some clues about the object's possible origin, suggesting it might have been ejected from a young stellar system where planetary formation processes are still actively reshaping the local environment. A scientific gold mine. So, 3I/Atlas represents, honestly, an unprecedented opportunity to study pristine material from another star system, and all without the expense and complexity of, interstellar missions. Dr. Michelle Bannister from the University of Canterbury is leading international efforts to maximize the scientific return from this rare visitor by coordinating observations across multiple wavelengths and telescope platforms. The object's extended visibility period, that's about 18 months from discovery to final detection limits, gives astronomers their longest observation window for any interstellar object to date. Spectroscopic analysis has already revealed the presence of water vapor, carbon monoxide, and complex organic compounds in the object's coma, offering direct samples of materials that formed around distant stars. Dr. Bin Yang from the European Southern Observatory noted that studying 3I/Atlas's composition gives us insights into planet formation processes happening in stellar environments with different metallicities and radiation fields than our own solar system. The object's active outgassing lets researchers probe its internal structure and composition, as solar heating liberates buried materials that have stayed frozen for millions of years. This natural excavation process really provides access to unaltered samples of the primordial materials from which alien worlds might form. Unanswered questions. Despite months of intensive observation, 3I/Atlas continues to pose fundamental questions that really challenge our understanding of interstellar objects. Dr. Olivier Hainaut from the European Southern Observatory identified several anomalous properties that resist conventional explanation, including the object's persistent brightness at distances where solar heating should be minimal. Size estimates actually vary dramatically depending on measurement techniques, with radar observations suggesting a compact, dense object, while optical measurements indicate a larger, more diffuse structure. The object's spectral characteristics show unexpected features that don't match known asteroid or comet compositions, suggesting either exotic materials or, unusual surface processes. Dr. Robert Warwick noted that 3I Atlas exhibits non-gravitational acceleration similar to Oumuamua, but the magnitude and direction of these forces don't correlate with observed outgassing patterns. Most puzzling is the object's variable infrared emission, which appears to cycle with a period different from its rotation, suggesting either internal heat sources or complex thermal properties, unlike any known solar system body. These mysteries really highlight how little we understand about the conditions and processes that shape materials in other stellar environments. The alien question. The possibility that 3I Atlas represents artificial technology has emerged as a controversial but persistent theme in scientific discussions. Dr. Avi Loeb from Harvard University, who famously proposed that Oumuamua might be an alien light sail, has noted several properties of 3I Atlas that could potentially indicate artificial origins. The object's controlled appearing trajectory and persistent energy emissions might suggest propulsion systems or power sources beyond natural explanations. However, Dr. Michelle Bannister and other mainstream astronomers argue that all observed properties can be explained through natural processes, citing the object's clear outgassing signature and spectral composition consistent with icy planetesimals. The artificial hypothesis faces significant challenges, including the object's fragile structure, which would likely disintegrate under artificial acceleration, and its chemical composition matching natural materials found in protoplanetary disks. Dr. Paul Chodas from NASA JPL emphasized that extraordinary claims require extraordinary evidence, noting that current observations, while intriguing, fall within the range of exotic but natural phenomena. The debate reflects broader questions about how scientists should approach anomalous observations and what standards of evidence apply when evaluating potential signs of extraterrestrial technology. Observing the visitor. Global telescope networks have mobilized in an unprecedented coordinated campaign to study 3I Atlas before it disappears beyond detection limits. Dr. Kelly Fast from NASA headquarters coordinates observations from ground-based facilities including the Very Large Telescope, Keck Observatory, and ALMA radio array, while space-based assets like Hubble and James Webb provide crucial high-resolution data. The James Webb Space Telescope has proven particularly valuable, using its infrared capabilities to study the object's thermal emissions and composition with unprecedented precision. Dr. Heidi Hamel, Webb's interdisciplinary scientist, reported detecting complex hydrocarbon signatures and isotopic ratios that provide insights into the stellar environment where 3I Atlas formed. Hubble's observations have revealed the object's detailed coma structure, showing jet-like features that suggest localized outgassing from specific surface regions. Amateur astronomers worldwide have contributed valuable photometric data, tracking brightness variations that help determine the object's rotation period and shape characteristics. This global collaboration really demonstrates how modern astronomy leverages both professional facilities and citizen science to maximize scientific return from rare astronomical events, creating the most comprehensive dataset ever assembled for an interstellar visitor. 3I Atlas has opened a new chapter in our exploration of interstellar space, providing unprecedented insights into the materials and processes that shape alien solar systems. While questions about its true nature remain, this cosmic visitor has demonstrated that our galaxy is filled with wandering messengers carrying secrets from distant worlds. Whether 3I Atlas represents natural phenomena or something more extraordinary, it has fundamentally changed our perspective on what travels between the stars. Which aspect of this interstellar mystery fascinates you most? Share your thoughts below. If you enjoyed this cosmic adventure, hit like, share with fellow space enthusiasts, and subscribe to Future Facts for more incredible discovery. Voyager 1, humanity's pioneering explorer, has defied all expectations since its 1977 launch. Now, more than 4 decades into its journey beyond the heliosphere, it continues revealing hidden cosmic phenomena. Recent encounters in deep space have confirmed fears long held by scientists about the unknown dangers and mysteries lurking in interstellar space, fundamentally redefining our understanding of the universe and our place within it. The birth of a star sailor. Voyager 1 emerged from an era of unprecedented ambition and innovation, Conceived during the 1970s as part of NASA's ambitious Voyager program designed to explore the outer solar system. Built by the Jet Propulsion Laboratory with project scientist Ed Stone overseeing the mission direction, Voyager 1 was equipped with an advanced suite of scientific instruments specifically designed to survive the harsh environment of deep space. Launched on September 5, 1977, it embarked on what would become humanity's most audacious journey into the cosmic unknown, destined to become the first human-made object to reach true interstellar space. The spacecraft carries humanity's hopes and dreams across the galaxy, immortalized in the included golden record containing sounds and images representing Earth's incredible diversity. This remarkable machine, weighing just 722 kilograms, would eventually travel farther from home than any other human creation, becoming our species' first ambassador to the stars and opening entirely new frontiers in space exploration that continue inspiring generations of scientists and dreamers worldwide. The Grand Tour. The Voyager mission represented an unprecedented grand tour of the outer planets, taking advantage of a rare planetary alignment that occurs only once every 175 years. Voyager 1's carefully planned trajectory included spectacular flybys of Jupiter in 1979 and Saturn in 1980, delivering breathtaking images and groundbreaking scientific data that completely transformed our understanding of planetary science. The spacecraft's discoveries included detailed observations of Jupiter's Great Red Spot, revealing its complex atmospheric dynamics, and unprecedented views of Saturn's intricate ring system that showed structures far more complex than anyone had imagined. Each planetary encounter expanded our knowledge of the solar system's architecture while using gravitational assist to propel the spacecraft toward its ultimate destination in interstellar space. Project scientist Edward Stone marveled at how the mission consistently surpassed all initial goals and expectations, providing discoveries that revolutionized multiple fields of astronomy. The Grand Tour established Voyager as one of the most successful space missions in human history, setting the stage for even more remarkable discoveries that would come decades later as it ventured into the unknown realm beyond our solar system. The Golden Record. Voyager 1 famously carries the Golden Record, an extraordinary phonograph disc containing sounds and images carefully selected to represent Earth's incredible diversity and humanity's greatest achievements. Conceived and overseen by a team led by renowned astronomer Carl Sagan, this remarkable time capsule includes greetings in 55 languages, music from various cultures spanning classical compositions to folk songs, and natural sounds from Earth's environment including whale songs, thunderstorms, and human heartbeats. The record serves as both humanity's ultimate time capsule and our most ambitious attempt at communication with potential extraterrestrial intelligence that might someday encounter the spacecraft drifting through interstellar space. The Golden Record's ingenious design included detailed instructions for decoding its contents, with diagrams showing how to construct a record player and locate Earth within the galaxy using pulsar map coordinates. Decades later, this golden disc has become an enduring symbol of human unity, curiosity, and our deep desire for connection across the vast cosmos, immortalizing our quest to reach beyond our planetary boundaries and establish meaningful contact with whatever intelligent life might exist among the stars. Years in the void. For more than 4 decades, Voyager 1 has journeyed through the vast darkness of space, continuously transmitting invaluable scientific data as it passed beyond the asteroid belt and entered the outer reaches of our solar system. Despite traveling more than 150 astronomical units from the Sun, a distance so immense that radio signals now take over 22 hours to reach Earth, its sophisticated instruments continue functioning remarkably well, providing unique insights into space weather patterns, cosmic ray behavior, and the complex dynamics of solar-wind interactions. Mission operations at NASA's Jet Propulsion Laboratory have faced unprecedented challenges including steadily weakening power levels, extreme communication delays, and the need to manage aging systems designed in the 1970s using modern computer technology. Engineers have performed miraculous feats of remote troubleshooting, developing innovative techniques to maintain spacecraft health across interstellar distances while conserving precious power resources. Voyager 1's extraordinary longevity represents a testament to both robust engineering design and humanity's persistent determination to explore frontiers far beyond our known boundaries proving that human ingenuity can overcome seemingly impossible technical challenges. Crossing the boundary. In August 2012, Voyager 1 achieved a historic milestone by crossing the heliopause, the mysterious boundary where the sun's influence dramatically diminishes and true interstellar space begins. This unprecedented achievement represented humanity's first tentative step into the vast galactic environment beyond our solar system's protective bubble. Scientific instruments on board detected dramatic changes in plasma density, magnetic field strength, and cosmic ray intensity, providing definitive evidence that the spacecraft had entered an entirely new cosmic environment never before directly explored by human technology. The spacecraft's signals confirmed that solar wind particles had given way to the interstellar medium, a historic validation of decades-old theoretical models about the heliosphere's structure and behavior. Mission scientist Ed Stone heralded this discovery as a triumph of human exploration, marking humanity's transition from inhabitants of a single solar system to active explorers of the broader galactic neighborhood. Subsequent measurements have continued refining our understanding of this complex boundary region, revealing unexpected turbulence and magnetic field configurations that challenge existing models. This crossing established Voyager 1 as humanity's first true interstellar spacecraft, opening entirely new chapters in space exploration and cosmic discovery. Signals from nowhere. Voyager's sophisticated instruments have detected enigmatic radio signals emanating from regions far beyond our solar system, creating one of the most perplexing mysteries in modern astrophysics. These mysterious signals from nowhere exhibit unusual patterns and characteristics that remain inconsistent with any known natural sources or previously understood cosmic phenomena. Leading the investigation into these anomalous transmissions, astrophysicist Donald Gurnett and his research team continue analyzing whether these signals originate from interstellar plasma oscillations, unknown cosmic ray interactions, or potentially even more exotic phenomena that challenge current understanding of physics. Some researchers hypothesize that these signals might result from interactions with mysterious magnetic structures, unknown particle fields, or previously undiscovered processes operating within the interstellar medium itself. The phenomenon has forced scientists to reconsider existing astrophysical models and may point toward entirely new physics operating in the vast spaces between stars. These continuing discoveries affirm that our galaxy remains profoundly mysterious, harboring phenomena that extend far beyond current scientific comprehension, and suggesting that interstellar space contains secrets that could revolutionize our understanding of cosmic processes and the fundamental nature of reality itself. The temperature mystery. Temperature measurements from Voyager 1 continue defying initial scientific expectations and creating new puzzles about the nature of interstellar space. Despite existing in the supposedly frigid environment beyond the heliosphere, instruments aboard the spacecraft have recorded unexpected temperature fluctuations and anomalously warm zones that challenge conventional models of interstellar medium behavior. Leading researcher Bill Kurth and his colleagues have analyzed extensive data suggesting complex thermal processes and unprecedented turbulence occurring in this mysterious boundary region between solar and galactic environments. These surprising findings significantly complicate existing models of interstellar medium properties, implying far more dynamic and complex interactions between particles, magnetic fields, and energy sources than previously theorized by astrophysicists. The temperature anomalies suggest active heating mechanisms that could involve magnetic field reconnection events, shockwave propagation, or entirely unknown physical processes operating on galactic scales. Understanding these thermal mysteries offers crucial insights about our sun's broader galactic environment and potential hazards that future spacecraft might encounter when venturing beyond our solar system. The discoveries underscore how much remains unknown about the cosmic environment surrounding our solar system and the fundamental processes shaping interstellar space. Changing course. Voyager 1's trajectory has exhibited subtle but measurable course changes over time, creating new mysteries about forces operating in interstellar space. These deviations appear to result from complex gravitational influences and unexpected interactions with interstellar matter that weren't fully anticipated by mission planners. Analysts at NASA's Jet Propulsion Laboratory, including project scientist Suzanne Dodd, have carefully documented trajectory deviations that cannot be completely explained by existing models of solar gravitational effects alone. The observed course changes may arise from interstellar wind pressures, gravitational effects from unseen cosmic structures, or potentially even interactions with dark matter concentrations or gas clouds drifting through our local galactic neighborhood. Continuous tracking and sophisticated data analysis provide valuable insights that inform navigation strategies and propulsion requirements for future deep space missions venturing beyond the heliosphere. These findings highlight the remarkably dynamic nature of the galactic environment and demonstrate the critical need for adaptive mission designs capable of responding to unexpected conditions. The trajectory modifications reveal that interstellar space contains forces and influences that extend far beyond current scientific understanding, suggesting that future interstellar missions will face challenges that remain largely unknown and unpredictable. Ghost in the machine. The spacecraft's onboard systems occasionally exhibit unexplained glitches and anomalous behavior that has led some mission specialists to speculate about a metaphorical ghost in the machine affecting Voyager's operations. NASA engineers continuously address these technological anomalies through increasingly sophisticated remote troubleshooting techniques, working across impossible distances to maintain spacecraft functionality. Some hypothesized issues relate to cosmic radiation impacts, gradually affecting electronic components, while others may result from normal aging processes in hardware systems originally designed for much shorter operational lifespans. The mysterious nature of these intermittent glitches adds a distinctly human element to the otherwise mechanical journey of Voyager 1 through the cosmic void. Mission engineer Linda Spilker frequently remarks on the extraordinary challenges of operating technology that's now over 4 decades old, while maintaining functionality across interstellar distances that test the absolute limits of human engineering capabilities. These technical anomalies serve as constant reminders of the spacecraft's remarkable resilience and the incredible ingenuity of the engineering teams who continue supporting its mission. The glitches also highlight how little we understand about the long-term effects of interstellar environment exposure on sophisticated electronic systems, creating valuable lessons for future interstellar mission design. Patterns within patterns. Voyager 1's continuous stream of scientific data has revealed intricate nested patterns in cosmic rays, magnetic fields, and plasma waves that researchers have dubbed patterns within patterns, complex structures that hint at deeper organizational principles operating throughout interstellar space. Leading physicist Donald Gurnett uses these unprecedented observations to develop sophisticated computer models of the interstellar medium's complex structure, revealing organizational patterns that extend across vast scales throughout our local galactic neighborhood. These nested fluctuations and systematic variations hint at turbulent cascade processes and magnetic reconnection events that may be actively shaping the galaxy's environmental conditions over cosmic timescales. The continuous analysis and interpretation of such cosmic complexity underscores the virtually endless frontier that astrophysical research represents and humanity's enduring quest to understand our place within the broader universe. Each new data transmission from Voyager reveals additional layers of cosmic organization that challenge existing theoretical frameworks and demand new approaches to understanding galactic physics. The discoveries demonstrate that even the seemingly empty spaces between stars contain rich, dynamic structures that influence cosmic evolution processes. These patterns suggest that interstellar space operates according to fundamental physical principles that remain largely mysterious, despite decades of intensive scientific investigation and theoretical development. Voyager 1's impossible encounter with the mysteries of deep space has both confirmed our worst fears and revealed profound cosmic secrets that challenge everything we thought we knew. As humanity's first interstellar ambassador, it continues providing unprecedented insights into phenomena beyond our solar system. The spacecraft's remarkable journey highlights both human ingenuity and the vast mysteries awaiting discovery in the cosmos. Which of these revelations surprised you most? Share your thoughts below. If you found this cosmic journey fascinating, hit like, share with fellow space enthusiasts, and subscribe to Future Facts for more extraordinary discoveries from the final frontier. A massive visitor from deep space is flying through our solar system. The object, now officially named 3I Atlas, has astronomers worldwide both fascinated and honestly a bit terrified. Officially confirmed as the third known interstellar object, it carries an eerie potential. Is this colossal traveler a natural body, or might it be, an alien ship? Recent NASA data has sent ripples of fear and fascination through the scientific community, questioning everything we know about visitors from the stars. The breaking discovery. The discovery of 3Y Atlas marked a historic moment in astronomy, revealing a visitor unlike any seen before. Detected moving at an extraordinary velocity exceeding typical interstellar speeds, it challenged existing models of natural celestial object behavior patterns. NASA's advanced telescopes captured data suggesting anomalous properties, including unnatural acceleration patterns and an unusual trajectory that frankly defies conventional gravitational explanations. Researchers like Dr. Amir Siraj from Harvard University have highlighted these deviations as potential indicators of advanced propulsion systems, setting off widespread debate about the object's true nature among the global scientific community. The stunning size of 3Y Atlas far exceeds earlier interstellar discoveries, measuring approximately 10 to 15 kilometers in diameter, and igniting serious discussions about whether we are observing a spacecraft rather than a natural cosmic wanderer. From initial detection through detailed spectroscopic analysis, the international scientific community continues grappling with extraordinary possibilities ranging from exotic comet composition to genuine extraterrestrial technology. The implications of either conclusion would fundamentally alter humanity's understanding of our place in the cosmos and the nature of interstellar space. The discovery story. The remarkable story of 3I Atlas begins with its initial detection by the Asteroid Terrestrial Impact Last Alert System in early 2025, when automated survey algorithms flagged an object moving with unprecedented velocity characteristics. Astronomers quickly realized its trajectory was hyperbolic rather than elliptical, definitively confirming its interstellar origin from beyond our solar system boundaries. Its enormous size, estimated to be several kilometers across, dramatically dwarfed the infamous Oumuamua and 2I Borisov, making it by far the largest confirmed interstellar visitor discovered to date. Dr. Robert Warwick, who previously discovered Oumuamua at the University of Hawaii, coordinated initial observational campaigns revealing mysterious activity patterns indicative of possible artificial influence or control mechanisms. The object's calculated path through our solar system appeared to be deliberately planned, with intriguing timing and orbital alignments that prompted intensive scrutiny from major observatories worldwide. Global astronomical networks mobilized for an unprecedented international data-gathering campaign, dedicating thousands of observation hours to studying every measurable aspect of the object's behavior, composition, and structural characteristics before it passes beyond detection range. A stranger in our midst. As 3I Atlas traverses our solar system, its extraordinary properties consistently challenge natural explanations proposed by conventional astrophysics models. The object exhibits complex outgassing patterns inconsistent with typical cometary activity, suggesting an internal energy source actively controlling its emission characteristics rather than passive solar heating. Advanced spectroscopic data reveals a surface composition featuring unusual metallic elements and compounds not typically found in natural asteroids or comets, sparking intense debate about whether it represents an artificial construct. Astrophysicist Dr. Marco Micheli from the European Space Agency has pointed out the object's highly reflective surface properties and precisely controlled thermal emissions as potential evidence of technological design and manufacturing. Most puzzling is the object's demonstrated ability to withstand intense cosmic radiation and extreme temperature variations without apparent structural disintegration or expected material degradation. These collectively puzzling characteristics make 3I Atlas a prime candidate in humanity's ongoing search for evidence of extraterrestrial spacecraft, fundamentally transforming how scientists approach the study of interstellar objects and their potential origins. The mounting anomalies continue defying conventional astronomical explanations while supporting increasingly exotic hypotheses. The predecessors. 3I Atlas follows in the cosmic wake of two notable predecessors that have, really expanded our understanding of interstellar visitors. Oumuamua, the first confirmed interstellar object sighted in October 2017, and Comet Borisov, observed in August 2019. Each of these brought unique mysteries that, honestly, challenged established astrophysical models. Oumuamua's extremely elongated, cigar-like form, and its completely unexplained acceleration away from the sun-puzzled experts around the world, while Borisov displayed more conventional cometary traits including visible outgassing and typical orbital mechanics. NASA researchers, including Dr. Karen Meach from the University of Hawaii's Institute for Astronomy, have emphasized just how important it is to compare these objects systematically to really understand the true diversity of interstellar visitors entering our solar system. Their cumulative comparative studies suggest a broad spectrum of both natural and potentially artificial objects traversing our galactic neighborhood, hinting at a far more complex and dynamic composition of the interstellar environment than scientists previously conceived. The sequential arrival of 3 on Atlas has really intensified international calls for establishing dedicated interstellar monitoring programs, capable of detecting and tracking future visitors with enough advance warning for detailed study. The cosmic journey. Traveling at incredible velocity with a definitively hyperbolic escape trajectory, 3I Atlas's epic journey from the depths of interstellar space really captures the imagination of scientists and space enthusiasts worldwide. The massive object appears to have originated millions, possibly even billions of years ago in a distant stellar system, and then embarked on this extraordinary voyage spanning both familiar and unfamiliar regions of our galaxy. NASA's Jet Propulsion Laboratory continues to support sophisticated computer simulations designed to understand how such enormous objects could, successfully traverse vast interstellar distances while maintaining structural integrity against all kinds of cosmic hazards. Dr. Alessandro Morbidelli's groundbreaking work in astrophysical dynamics specifically highlights the numerous challenges faced by such ancient cosmic voyagers during their extended journeys through space. The object's observed interactions with solar radiation, gravitational fields, and interplanetary magnetic environments provide invaluable scientific data about interstellar medium properties, directly benefiting ongoing research into cosmic evolution and galactic structure. Its successful arrival suggests either extraordinary durability of natural materials or perhaps possible artificial construction designed to withstand the harsh realities of long-duration interstellar travel. A scientific goldmine. The unprecedented arrival of 3I Atlas presents an extraordinary scientific goldmine, offering unique insights into the chemistry, physics, and material properties of objects originating beyond our solar system. NASA's James Webb Space Telescope has played an absolutely pivotal role in detecting previously unknown spectral lines within the object's complex electromagnetic emissions signature. Dr. Stefano Bagnullo leads international collaborative investigations that have successfully revealed unexpected complex organic molecules and exotic metallic compounds never before observed in natural celestial bodies. The accumulated observational data promises to shed revolutionary light on conditions prevalent in the early universe and the fundamental processes governing planetary system evolution throughout cosmic history. Intensive collaboration among international observatories has dramatically intensified, strategically leveraging multi-wavelength observations across the electromagnetic spectrum to capture the most complete scientific picture possible of 3I Atlas's true nature and composition. Scientists worldwide anticipate that these ongoing investigations will yield groundbreaking revelations capable of fundamentally reshaping humanity's understanding of the cosmos, interstellar chemistry, and the potential for artificial objects traveling between stellar systems. The scientific community recognizes this as a once-in-a-generation opportunity for paradigm-shifting discoveries. Unanswered questions. Despite extensive international study utilizing the world's most advanced astronomical instruments, there are still, numerous fundamental questions about 3I/Atlas that continue lingering without satisfactory explanations. Its documented orbital anomalies, mysterious surface composition, and those completely unexplained outgassing patterns consistently defy comprehensive scientific explanation using established astrophysical models. The persistent inability to detect conventional volatile substances typically associated with cometary objects fundamentally challenges existing theoretical frameworks and classification systems. Significant discrepancies between observed brightness variations and thermal emission patterns suggest complex surface interactions or perhaps concealed internal energy sources operating according to unknown principles. Leading astrophysicists like Dr. Sarah Seeger propose increasingly exotic alternative hypotheses, including the controversial possibility of artificial origin and extraterrestrial construction. The object's complete behavioral profile remains frustratingly elusive to researchers, continuously fueling heated ongoing debates within the scientific community, while at the same time, demanding expanded observational campaigns to decode its persistent enigmas. Each new measurement seems to raise additional questions rather than providing definitive answers, suggesting that 3I/Atlas may represent phenomena extending far beyond current scientific understanding. The mounting mysteries challenge fundamental assumptions about what constitutes natural cosmic objects. The alien question. The profound alien question has resurfaced with renewed scientific vigor as 3I/Atlas continues exhibiting multiple characteristics that many researchers believe point definitively toward artificial origin rather than natural formation. Professor Avi Loeb, the prominent Harvard University astrophysicist and former chair of the astronomy department, argues compellingly that the object's unprecedented properties remain fundamentally inconsistent with any known natural explanations proposed by conventional astrophysics. He suggests that 3I/Atlas could represent a genuine extraterrestrial probe deliberately sent to monitor or actively interact with our developing solar system civilization. This provocative and controversial assertion has sparked intense discussion within both rigorous scientific circles and broader public spheres, challenging established academic orthodoxies. Critics appropriately caution for maintaining rigorous evidence-based standards over speculative interpretations, but the continuously mounting observational anomalies increasingly pressure researchers to seriously consider dramatically expanded paradigms that accommodate the possibility of cosmic intelligence. The escalating debate highlights humanity's gradually shifting worldview as we potentially stand on the threshold of first contact with evidence of non-human intelligence. The implications of either confirming or definitively refuting the artificial hypothesis would fundamentally transform human civilization. Observing the visitor. Intensive observations from major global telescopes have dramatically intensified as 3I/Atlas approaches its closest point to the Sun, offering unprecedented opportunities for detailed high-resolution imaging and comprehensive spectroscopic analysis. World-class astronomical facilities including the Very Large Telescope in Chile, NASA's Hubble and James Webb Space Telescopes, and extensive international survey networks have coordinated completely unprecedented observation campaigns. Dedicated research teams monitor measurable changes in brightness, trajectory, and emission patterns on a continuous daily basis, seeking any anomalous behaviors or structural modifications. The comprehensive data collection efforts specifically aim to capture transient phenomena including possible energy flares, potential communication signals, or unexpected structural alterations that might reveal the object's true nature. The global scientific community universally anticipates that these intensive coordinated observations could potentially provide definitive answers regarding the object's fundamental nature and ultimate origins, possibly marking a genuinely historic moment in humanity's ongoing search for extraterrestrial life and intelligence. The observational window represents our species' only opportunity to study this extraordinary visitor before it disappears forever into the cosmic void. Dawn of a new era. As humanity stands precariously on the brink of potentially transformative cosmic discoveries, the enigmatic presence of 3I/Atlas fundamentally challenges long-held assumptions about our species' place within the vast universe. The object's increasingly complex behavioral patterns hint at the possible existence of a greater cosmic network and unknown intelligences actively operating throughout our galaxy. Leading scientists now seriously consider the revolutionary possibility that Earth and its inhabitants might have been systematically observed for millennia by advanced civilizations possessing technologies far exceeding human capabilities. This profound paradigm shift compels our species to completely re-evaluate our cosmic role, not as passive observers gazing outward at an empty universe, but as active participants within a dynamic, interconnected, and potentially populated cosmos. The ongoing revelations emerging from detailed study of 3I/Atlas herald what may represent a completely new chapter in both cosmic understanding and human evolutionary development. Whether the object proves to be natural or artificial, its mere presence has already begun transforming how humanity perceives its cosmic significance and future destiny among the stars. The dawn of interstellar awareness has arguably already begun. The unprecedented insights from 3Y Atlas have ignited both excitement and genuine concern within the global scientific community. Whether this massive object represents natural phenomena or artificial technology, its passage through our solar system forces a profound reevaluation of cosmic possibilities. As intensive investigations continue, humanity waits on the cusp of possible contact and discovery. The universe may be far stranger and more populated than we ever imagined. Which aspect of this mystery fascinates you most? Share your thoughts below. If this cosmic investigation intrigued you, hit like, share with fellow space enthusiasts, and subscribe to Future Facts for more incredible revelations.